Login accepted.
So who am I? I'm I'm back. I was here from the intro meeting. If you already forgot who I am, my name is Dylan. I'm a fourth year CIS now. Oh man, that means I'm old. My handle on Discord is Nigerald. I'm an ex-intern at Exports Red. I just flew in yesterday and I had no time to look at these slides. So we're gonna start balling. I was doing some adversary simulation stuff over there. So I was writing a whole lot of Windows payloads and whatnot, a lot of malware. Then I was uh I was on the CPTC team starting in 2021 until 2024, where I was a captain my last year. Also did a lot of Windows stuff there. And for CCDC, with all my Windows experience, they put me on Linux for all 3 years that I was doing it. So I helped out with Linux my first year, and then the next 2 years I was basically the Linux lead doing Linux things. So yeah, that's awesome. John Linux, unfortunately, the Cooper genius. Yeah. Okay, so agenda for today. We're just going to be talking about services. It's in the title of the week. We have a few objectives. We want to identify what services are and what services are present. We talk about services a lot when it comes to CCDC and computers in general. There are, if we're being specific about the terminology, they're separate things. So we want to first clarify what those are by definition, and we're going to talk about which ones are actually common in CCDC, and we're going to try to hopefully we'll leave this meeting with an understanding of with an understanding of the methodology when dealing with services. And when I say the methodology, I mean we want to know how to install, troubleshoot, configure, do all that stuff. We want to make sure we know how to triage and identify what services we're running. And in the case for CCDC, which ones are relevant and which ones are not so relevant for what we need to do. So what is a service? Anyone have any ideas? Someone want to give me any definitions? Want to say some words? I bet you know. I'm not going to ask you. Okay, yeah. So there are I'm not gonna, I don't have a formal definition, but at least from our particular use case, there's sort of two definitions of service I'm going to go off of. I'm going to call them host services and business services. So a host service is a normal service on your computer. And what I mean by normal, I mean, it's just effectively a process that's running in the background that does something on your computer, which means technically anything can be a service if it's running in the background, right? So I don't know, like some sort of printer API on your computer. If you have something that, oh, I can't think of any services off the top of my head. That's awesome. And then you have business services, which are some sort of functionality that a server is going to serve, and it's relevant to a business. So this could be like a website, which is client facing that clients will interact with, or maybe an internal website that employees within a company will use for whatever reason. It could be like an HR portal or some sort of, I don't know, like GitLab, for example. These business services serve some sort of the distinction that I make between these two is that a business service serves some sort of purpose and can come in sort of different shapes and forms, whereas a host service is explicitly a sort of background process that's running on your computer. Business services will typically come in the form of one or more host services, whereas a host service doesn't necessarily mean it's a business service. For example, on Linux, you have cron, which is something that runs in the background running sort of like automated tasks. That's not necessarily a business service, but another host service you might have is an Apache web server, which can also serve a business role. And if it is, then we could also classify as a business service. When it comes to business services, you generally want to maintain uptime on them. There are these things called SLAs, like service lifetime agreement, or something like that. Basically, there's an obligation that there's a specific uptime that the service needs to uphold, and if it does not, then the the organization is at a breach of a contract and is subject to some legal penalties. At least that's my understanding of it. And in CCDC, this comes in the form of your service is down for 20 minutes. You are going to start losing points on top of not making any points. Man, really, I wish I had my notes with me. So, host services. On Windows, this is what it might look like. So if you open your Windows key, click R, and then type in services MSC, this brings up the service window. This is where you can see all your host services. Oh, wow, yeah. So one example of your host service is your antivirus. It's not necessarily serving a business role. It's not clients aren't interfacing with your internal employees, are not using it to do anything. But it's something running in the background of your computer. In this case, it's gonna protect you. Then there's a whole bunch of other things. Well, oh, it's like an essay, dude. So, and host services on Linux. Linux mostly work with the command line. So you're gonna have, so we'll be operating with the command line on this. And we can enumerate this if you're running a system that has system D, which is going to be the majority of them, unless you're starting to run some more esoteric stuff. But generally, most stuff in CCDC will have system D. This will allow you to use something called system control or system CTL. And from here, you could run list units, type equals service to see what stuff is running. And if you can pipe it into head, then you could just, in this case, I'm just seeing like the top 10 services. I think it's alphabetical in this case. You can see it says some stuff like there's cron, there's Docker. So host services, but may not be serving a business role, so we might not classify them as a business service. If your host doesn't have systemd, you could still probably use service. This one's also relatively common. It's a little jankier. It's just older to my understanding. Not as much information either, but you still get an idea of what processes are running in the background or what processes are being managed by running in the form of a service. Moving into business services though, business services aren't necessarily one of those services I was talking about. They can be sort of a combination of multiple things. So typically when you have a business service, you have some sort of client, and this client, well, it's a bit weird because client uses a client. So I'm going to differentiate by saying you have a customer, a client, and then the service, right? So the customer could be an actual like customer, or it could be or it could be an employee that's using an internal business service. They're going to use some sort of client to communicate with the business service to get whatever information. Well, generally, it's going to be information they want because information can come in any way, shape, and form. And this business service may have other sorts of dependencies. Not all services are all encompassing, right? So let's try to let's try to contextualize this with more of some sort of example. I got Roblox, all right? So Roblox is a business service, right? You have your customers, which in this case are people trying to play the game, and then the actual service they're accessing is a mixture of the web portal and the contents that it's serving, the games that you can play on it, and whatever else anyone can do with this, right? So trying to fit our understanding of Roblox as a business service into the model that we have earlier, it might look something like this, right? Where the player is going to be the customer, right? And the client in this case is going to be a web browser. The web browser is going to access the web server, and the web server is going to interface or communicate with the databases to get the information it needs to serve to the end user. Putting these all together, we could say that the business, like the Roblox business service is sort of encompassing the web server and the databases. I don't actually know the architecture of how Roblox does it, and it's probably not like this. I'm just using this for the sake of an example. And the reason why this is sort of relevant for CCDC is because oftentimes you'll have a bunch of running host services, and some of these host services will be business services, and a part of the challenge is to figure out which ones are and how are they interconnected. So, how can you secure a service? That's a great question. I have no idea why I put in these slides. Okay, well, and this is something personally that I did for CCDC. I came up with this. It's an actual process. I just sort of fit it into our particular use case in CCDC. So threat modeling. Does anyone have an idea of what threat modeling is? Great, me neither. But I made these slides, so we're gonna roll with it, right? So I like to understand. I understand threat modeling as the process of figuring out what threats sort of exist to attack some sort of object. In this case, our object that we're dealing with is a service. So you have to figure out what is the attack surface of a service, how can attackers impact it, and what are the different ways that it can be impacted, and then how can we address those, right? So first, when it comes to threat modeling, and in the case of CCDC, we want to think, okay, how does this service actually function, right? What is the role of the service that we've identified to the business? Because its role can changes how it can be impacted by an attacker, right? And then when we think other questions we might want to think about are how does the service work from a technical standpoint, right? Because that's getting into those details is going to be covering how an attacker can actually attack it, right? Generally, a service is going to have ports because if a client is going to communicate with it, communication occurs over the network. So you're going to end up needing some ports to do that. And as I was talking about earlier, services usually aren't all encompassing. They may have dependencies. So an attacker can attack a service by some of the other processes that it depends on. And then we're also going to try to identify based on this, like what sort of attacks can they do, right? If we're serving a website, right, and the website has some content that our customers are expecting, there are different things that an attacker can do to impact that, such as performing some sort of denial of service. If they're denying service to the website, then well, they're not customers aren't getting the information they want, so they get angry, and that's not good for us. Same with similarly with defacement, if the contents are altered or they're just straight up deleted, that's also bad and can be argued in a similar case as denial of service. And in the case of CCDC, we also want to think about what does the impact of the exploitation have? If they deny service or deface and make corrupt the information that we're serving, that will affect scoring, but it doesn't have as much of a impact on our security of our network, right? Well, maybe they get something else, such as command execution or some sort of information exposure that they can use to breach our network. And that's going to also be more concerning. And we want to think about that. And then when we're considering attack, we also want to think, how do the attacks actually work? And this ties into how does a service function on a technical standpoint, right? If an attack requires network access or authentication, then we can think, okay, they're going to need ports or they're going to need credentials. And that affects how we can apply our mitigations. Mitigations are the sort of the last thing that I like to think about because I want to make sure I understand how the service works and how it can be hit before I can figure out what was the solution, because I don't want to just throw random solutions and hope they stick. We want to actually understand what's feasible and then address those. So when it comes to mitigations, thinking about, is there a configuration or a patch that you can do to mitigate the attack, right? If there's a configuration that you could just enter and it doesn't affect the function, it hardly affects the functionality and it completely remediates the attack, that's awesome. And if it's quick to do, even better, right? But if you have to do like a patch, then you have to think, okay, well, how do I download the patch? How long is that going to take? And you're going to have to start weighing your options. And since the majority of attacks are going to operate on a network level, it's also really easy to think about, okay, how can you mitigate the attack from a network standpoint? So through firewalls, right? Can you do a host level or a network level firewall? Which one's quicker? Which one's easier to perform? Because in the case of CCDC, you're on crunch time. You have 8 hours. And realistically, those first 15 minutes are going to be the most important part of the competition. And if none of that is possible, right? If there's no way to completely remediate the tech because it's either not feasible or it's just going to be too costly to do that, then maybe you can think, okay, can you sort of reduce the risk of or reduce the impact of the attack from having, so can, if you know you're going to get impacted by it, can you sort of isolate that impact, right? If you know that there's going to be command execution on a web server, for example, and you know you can't prevent that, maybe you could isolate the command execution to be within a low privilege context, for example. This is something that my manager liked to say a lot. Is the juice worth the squeeze? And this is really important for CCDC because, like I said, you're on a time crunch. So you want to have the most impact when you're configuring a service with the least amount of effort. Like if you could have one line that fixes all your problems, that's what you're going to want to do, right? Sure, it might not be the most comprehensive solution or it might seem janky, but given the constraints, you kind of got to do what you got to do, right? So, for example, let's just say one of our services is a database, right? And that database, we don't know anything about it because in CCDC, you're just dropped in and you got to figure it out. So all you know is you have a database, right? And you have best practices versus we're in CCDC, right? So best practice might be something along lines, yeah, maybe we should audit the database, configure with the principle of least privilege, make sure we have a backup set in place, make sure, I don't know, like 15 other things, some sort of frameworks tell you to check. Or in the case of CCDC, you could be like, well, what if we just firewall the database to be within the relevant subnet? Because realistically, no one, people aren't accessing the database externally. They're accessing it through some sort of middle server, such as a web server. So that means only the web server really needs it. So let's just maybe we just restrict access to the database to a subnet, and we could do all those best practices later. Never. Don't take this as actual like professional advice, so please follow best practices or something. I think Evan supports that. So let's talk about what services exist in CCDC now. Damn, really need to be hydrated today, I guess. So what services exist? I like to separate at least my understanding of services between some more traditional stuff and then other stuff because I'm great with words. So the traditional services are these sort of uh self-host things that you could self-host, and they're relatively, I guess, more simple in architecture. They're kind of standalone, like a web server. It's just gonna serve contents. Remote access servers, they're host services that provide remote access to the machine that they're running on, databases, LDAP, and all that stuff. Right? They are services that can run on a single computer and through a process that sort of runs as a host service to provide all that functionality. And a lot of these stuff are more like old school. I understand like there's been software existing for this stuff for decades now. And then you have these sort of other stuff is what I call them. So like software as a service, platform as a service, cloud computing, and other stuff. My understanding is under the hood, they still use these fundamental traditional services, but there's often like such a big mesh of them and they're all interconnected in a way to provide some more abstract functionality. We don't really deal with them in CCDC, but it it's good to note that that sort of stuff does exist. And I mean, I guess we can kind of technically do work with them a bit in CCDC in the Western region. We have to deal with cloud, but we within our cloud environment, we still end up using traditional services or at least like some sort of form of that. So whatever. Yeah. So in CCDC, you'll have between 10 and 30 of these, 10 and 30 of these business services effectively. Some of them standalone like a single web server, or maybe they're scoring like three different components that they're scoring the database as well as remote access to the server and the web server itself. And this is going to cover only 40% of your scoring, but it's the part that everyone stresses the most out because while it only incorporates up to like 40% of what you can gain, it could be like 100% of what you lose because they services in CCDC also there's penalties, but that the penalties can go outside of that 40% of scoring, to my understanding. I didn't actually do the calculations, but you can go well into the negatives. And the relevant services in CCDC, you got web servers and web applications, more on that in a bit. You have file shares, mail servers, remote access like SSH and RDP. I feel like you guys are a little familiar with that by now. Databases, DNS, and even things just running as containerized applications, which really isn't a service in itself. It's more like it's just some like the same as what we already covered, but just running in a different runtime. So we'll be moving into the lab now. Are there any questions about what we covered so far? That's great. No questions means we're always in for an amazing time. So for the lab, there should be a week 6 pod that Evan fixed up about 30 minutes ago. God bless. The credentials to there's gonna be a Debian machine and a Windows server. The all the credentials there's just the password for everything is bruh. It's easy to remember. Definitely don't use it for anything outside of this. I swear. And for this lab, we're gonna have multiple goals. We want to understand what each service we're gonna cover is. The stuff I have in bold are the stuff we're gonna cover, which may or may not show up in the tryouts. I actually don't know because I haven't been paying attention to the planning process of that. I hope they are, because else this would just be completely irrelevant. Are these claim? Oh, I was gonna ask if these claims are factual, but word, awesome. Well, I know we have red team planned. So for each of those bolded services from before, we're gonna go over them. We're gonna try to understand functionally what they do. We're gonna go over some examples of them. We're gonna try to manage them a bit. We're gonna install, do some configurations, try do a little funny stuff with them, and then we're not really gonna do this from a technical standpoint. We're more just gonna think about it and hope you remember and build off of that within these 2 weeks that you have until the tryouts. We're gonna try to threat model each of these services with a CCDC in mind for the context. So remote access, it's anything that gives you access to a machine remotely. Isn't that crazy? Remote access means access remotely. Word, right? Different shapes, different forms. In other words, there's just like a bunch of protocols which do this, and they all run on different ports. They function differently, but they effectively have like the common rule of if you authenticate, you can access a machine remotely. You have SSH, RDP, VNC, and WinRM. Some of these require a bit of authorization, looking at your RDP. And the other ones I forgot about, but I think you can enforce authorization on them, such as SSH. SSH runs on port 22 TCP, RDP or Remote Desktop Protocol 3389. VNC runs on 5900 and then 5901, 2, 3, 4, so on, from what I understand. And WinRM, which is 5985 or 6, depending on whether or not it's configured with TLS. So for the remote access lab, here are the instructions. I'm gonna hopefully we could get this down within like 20 minutes, and then I'm going to do it live and hope it works, I guess. So on the Debian machine, I want you guys to install OpenSSH server and XPRE RDP, which is an RDP client. And then on Windows, I want you to install the RDP server. I gave you guys a Windows server, so you should be able to. And if you're not able to install RDP on a Windows server, something's really weird, and I'm gonna be concerned about my understanding of everything at this point. And then for our lab, we want to be able to SSH into Debian from Windows. Server 19 should have an SSH client. I didn't check that, but it should. Okay. Good. then since we install an RDP client, we should be able to RDP from Windows or from Debian into Windows. And then we're gonna try to mess around with stuff a bit. So if we add a username user to both systems, and in the case of Windows, we're gonna add it to the remote desktop users group. We're gonna try to do that same remote access as we did earlier, but rather than using the administrative credentials, we're gonna use a user that we just added. And then we're gonna delete them or delete them from the group, see if we can access the systems, and I wanna see if we're able to check on the status of our services. So I'll give us until probably like 2:05 to get that figured out. Uh yeah. And then I'll go over it and we'll talk about threat modeling sometime. So I'll check back in a bit. If you have any questions, shoot them in Zoom. Throw them in Discord or my Discord DMs. Just don't shoot me, and we'll be good. If you can't hit the internet, Evan tossed a command in the Discord. There should be a command to run on your router. Apparently, our routers are now switched to VIOSes instead of PF senses, so I was unaware of this change. And this seems to be in, I don't know if this is affecting anything, but is that part of the template that you changed? Like, did you just not add that in the template router? Oh, I mean, it's like in the, is it because you forgot to put in the base template? So this is, okay, this is a result of the switch and I can say that. Yeah, so you might wanna run that command on the BIOS router. If you want to have internet and download packages for this lab. Hello? Hopefully, hopefully if we were working on this, we made a bit of progress. I'm gonna go walk through this part of the lab now, and then we're gonna go over some threat modeling questions. If you guys feel like answering anyways. So anyway, yeah, so let me resume my share and go over the whole installation configuration steps I was talking about. Oh, this is gonna be really inconvenient to type with one hand and hold the mic with the other. Oh, it looks like I also have to fix my internet because looks like my router is having the issue, so yeah, my router doesn't work. Oh, this is a lot of typing. Oh, there is? We are so bad. Yeah, I didn't know there was a tab autocomplete. The last time I did this, it was all manual when I was last configuring BIOS. Huh? Egg? Egg. Okay, so, uh, wait, there's some questions in, the room. So we're gonna go over the installation process for OpenSSH server and RDP now. So I'm enabling RDP right now for the Windows server, which is going to set up the RDP server, or RDP service, and just updated packages on Debian. So now we can now install XPRDP and OpenSSH. Wow, XPRDP doesn't exist in this package manager. That's awesome. I have to Google this one a bit. Great. Oh, I tested this on a different version of Debian. Looks like this one's not very happy with me. So may hold off on that for a bit. Yeah. Oh, I just saw Max drop something in the chat. That's crazy. Appreciate it. I found it on Google on my phone because I'm not pulling up Google on my laptop. Don't worry about it. Okay, so now we have our RDP client set up and our SSH server. We can now go on to the next steps, which are adding a user to both systems. I don't want to do that right now. So we're just going to remote into each system right now with with the servers that we set up. That's crazy. Remote access gave us remote access. Let's try it the other way around now. That's crazy. Remote access is still giving us remote access. For the sake of time, I'm gonna skip this other part. The only thing that this was supposed to indicate was that you either need to be an administrators or remote desktop users to actually be able to use RDP on Windows, whereas Linux, SSH by default, you could SSH as anybody but root, depending on your installation. Did anyone figure out how to check the status of the RDP service or the SSH service? Would anyone like to give me a command to do so if they figured it out? Person that Evan is pointing at, would you like to speak? I don't know names. Okay, I guess not. All right, that's crazy. Let's figure it out real quick for the sake of time. Wow, I got kicked out. So we're gonna check the status of RDP from our RDP session because I got kicked out of my Windows. The screen dimensions are screwed up. It's actually over. I'm not gonna do that anymore. Wow, remote desktop services. I wonder what happens if I turn this off. It looks like I can't RDP anymore. That's crazy. Looks like turning off the service makes us not able to use it. And on Linux, oh wait, another way that we could try to check for this is on Windows. We check our ports. So if we check our TCP ports and look for the things that are listening, we can see 3389 is gone. Let's turn it back on. I hope this turns back on properly. There we go. We do the same on Linux. Technically, you should be using SS since it's the newer one, but I like using netstat because old systems have netstat. SS blunt tech P. Then we can see 22 over here is being run with the SSH process, and we could check this with system control. We could also stop or restart it over here. Okay, so yeah, that's a very basic installation and usage of both RDP and SSH. What do you guys think? You know, if we're gonna try to do a little bit of threat modeling on this service, what do you think an attacker can? Well, what's the attack surface of an RDP server and an SSH server? Let's say they were business critical, so on top of being host services, they're business services, and customers need to remote access in, right? What do you think an attacker can do with these with services? Well, actually, let's go back to the funky diagram I wrote. Okay, what do these services do? Let's start off with that. Thank you, Bill, aka Todd Fob, aka Mr. President. Thank you for your answer. Yes, these services provide remote access, but like how do they do from a technical standpoint? What was give us like the main prerequisite for this to what's the main prerequisite for this remote access to be granted? How do these services operate? Like how are you able to remote in over the network? Yes, so we need credentials and we also technically need network access, right, with the port. So let's just say, okay, so if we need credentials and we need network access, how can we prevent an attacker from which one seems easier to implement if we want to prevent an attacker from using these? As I think we can already sort of get a feel of the impact of an attacker being able to leverage these. They get remote access just like we do. Not the greatest, you know, that's not fun. I don't like it when someone else is in my computer. Yeah. So the user must be authorized. They typically are, but they also need, for the most part, you just mainly need credentials and network access. So how can we mitigate that? Zero trust. I don't feel qualified to speak on that one personally, but I think that's technically valid, but can we be more specific of a control or some sort of configuration or some sort of action that we could implement on a server to mitigate or cut off an attacker's access? how can we leave valid users to have remote access while cutting the attackers off? Public and private keys, that works. That's valid if we are using keys and attacker and we switch keys and the customers have the keys and the attackers do not, then yeah, password authentication can't be used. I don't know, I mean, Windows has some sort of form of PKI for authentication, but I don't know if you can use keys in particular for over RDP. I know there's like some sort of smart card line. I don't think that's applicable here. Uh, but I will say like the easiest thing we can probably do, and this is just strictly speaking from my experience, within CCDC itself, not real world, within CCDC in particular, is rotating our credentials and making sure that attackers just don't have the creds that we're using. Because if the client is aware of the creds and the attacker doesn't have them, I mean, and because we need to make sure network access is still granted so clients can use it, attackers can't access it because while they have network access, they don't have creds while clients have both. So that part that basically covers it. Remote access is like a fairly simple service to deal with in CCDC, and generally if it's scored, we'll just rotate credentials, and if it's not scored, we either turn it off or use key authentication. And the reason why I'm asking us to think of like more specific examples is this is sort of directly playing into CCDC and the trials which emulate the CCDC environment. I understand that there are certain practices and things we would want to implement, but if we don't know how to implement them from a technical standpoint, they don't really help us in CCDC because we could think of all the interesting solutions that we want and the best practices, but if you can't actually implement them within the competition, they don't really give us any value. That being said, moving on to our next set of services that we're going to go over, file shares. You share files, like how remote access gives you access remotely. There's different, just like with remote access, there's different versions or different types of software that can be run as services that provide this capability, such as FTP, which exists on Windows. There's like a sort of built-in FTP thing. Things like files or something. I don't know. No, that's XAMPP. Yeah. No, I'm talking about like the IIS thing, right? It's like it's built in sort of. Not. It's like you have to install. It's a built-in package. There you go. Right. That's the wording. Uh, Linux, you have a million different FTP servers and Samba. We don't talk about Samba though. Samba's weird. I don't like it. These will run on ports 20, FTP runs on port 21 and 20 depending on the configuration, whereas Samba runs on port 445. Different protocols to do the same thing, which is share files. So we're also going to keep this lab pretty short, hopefully, for the sake of time, since we have 2 more to cover after this. So for this lab, if you can install FTP on Windows, you should. I didn't post I didn't link a guide to it, but you just search up like install FTP server on Windows through like you could either do XAMPP or IIS. That should show up and you could follow that. Debian if you install VSFTPD. And then we're going to configure guest authentication for both of those FTP servers, put some files in there and then access and read them. And then we'll go over checking the status of FTP and accessing it from the other machine. And if there's any questions, feel free to toss questions in Zoom or to message me in some form. That probably isn't carrier pigeon. That one's a little tough to read. Okay, hopefully we've had enough time to work on this now. We can try to speed run this and continue the whole stuff that we were doing with the remote access lab. So I'm gonna go ahead and install VSFTPD on Debian and FTP on Windows. I kind of don't know why I'm supposed to install a web server to be able to install FTP, but you know, that Windows, yeah, I guess.
You don't want to serve what with your.
Well, to install the FTP, so I had to install the IIS. Yeah, well, I mean, I guess I could remove the web server part. It's just not intuitive. I hate this.
Yeah, I don't think you.
Yeah, I guess you don't need the web server. So you can have IIS with no web server, even though IIS
Yeah.
is usually synonymous with the web server.
Yeah. FTP is also internet
I hate you.
information.
Ignore the K3S service. We could just hit enter every time we see that. I swear it doesn't do anything.
I swear everything's already installed on the system. That's why the OS is so big. It just enabled.
Yeah, that's.
I agree with this reading. I'm not like why.
That's why.
And now using the stuff that, using the same methodology or steps that we did earlier, we can check the status of our FTP to make sure it's up and running.
No, that's perfect. Yeah, that's like yeah.
And now we can see FTP is probably running because port 21's open. To be honest, I have no idea how I turned on FTP. I just clicked a few buttons and it worked. I've never done that before.
Welcome to Windows.
But that's why I like Windows, because you click a few buttons and it just starts working sometimes. Okay, so now what was the next steps? We're gonna add some files to the FTP roots of both of these, and we're gonna try to access them, and we're gonna also do guest authentication. A lot of times on Linux, your configuration files for your host services, which may or may not be business services, will be located in etc and then service name.conf. There's the configs differ by service and how they parse them. This one's a little more intuitive. It just says yes and no a bunch of times. I'm gonna say anonymous yes for the sake of the lab. Might not want this on normally. depends on the business use case of, well, if there is a use case for FTP in the business and how they want it to be used. Maybe they do want it to be anonymous. It is what it is. And after you make a modification, you just gotta restart it. Theoretically, it will work. We'll try that from the Windows machine. Bruh.
Wait, it's the license series.
License expired.
I thought the template,
The template is set there.
Yes.
so we have very legitimate copies of Windows. They turn off every hour, I guess. That's new to me.
That's not new to you.
It's not new to me. Yeah, give it a minute, I guess.
That's gonna be part of it.
Or the SDC reconstruction is also gonna be the 800 orphan VMs.
Oh, no, those are all getting deleted.
It's okay. I've run Beaver Valley already.
I'm just wondering, like, if you wanted a while, like you want to say like let's say like a Windows. And you want to have to do you like allocate a bunch of keys?
Oh, there's a server on GitHub. There's a tool on GitHub that people use to help out for that whole automation. We're just lazy.
It's not a hit.
Oh, no,
Windows has like its own licensing service.
yeah, but there's a tool on Git to help get around things.
Oh, if you want to do it like just.
Oh, you're talking about legitly.
I tell you how one was done to my job. Asked me to give him all the like what? I'm like, sure. I'm not.
You should say, you don't need keys for that much. Like, you could have gone for running so bad, like, you know, I had to say.
So to test our guest FTP, we're just gonna FTP to the server. Oh wait, I forgot to put anonymous.
Like, you know, like just got better.
So it looks like our anonymous configuration worked from the little edit that I made in the vsftp.conf. I forgot how to change modes.
Oh. Oh, type has to be two S's.
Syntax is a little different than I remember.
What is it, set has to be? Set keyword.
Or you try to. But it's like. Oh, is that?
Yeah, it's a client side thing. I just forgot the command. I give up.
I swear it's past B. Wait, how much?
I also swear it was past B.
He was looking around.
The way you describe it, it's usually like vertical. It sounds like there are that's not like people.
Oh, that's a good idea. No,
HTTP server.
You know, Updog?
What's Updog?
It's the thing on GitHub. It's the Python file server thing. It's like a slightly beefed up version, but simply HTTP.
Got Webster. Where is it? Oh no, we have a file server. The inject tracking.
Hey Max, if you're here, do you happen to remember how to switch between active and passive on the client? I completely forgot. Insane. We all, somehow, within the course of one summer, we all forgot how to switch between active and passive collectively. Huh? Oh, so it's just available on this client and not the Windows client.
Yes, that's how it is.
Searching up differences between active and passive.
Wow. I'm gonna disable the firewall to get this working.
You have to do like the firewall mode. Let me show you. It like it whole punches your firewall.
Why the Windows? I think it's not support.
It does say, but oh, the client. Wait, I swear to God.
No, I think yeah, this is the last one.
Oh, yeah.
We had it.
Oh, yeah, the client isn't by Windows.
Yeah.
Yeah, we spent like a month figuring out the FTP client, only to realize it didn't. That was so funny.
Okay, so the FTP root on Linux, at least for a lot of the distros I've worked with, by default it's in serve FTP. So I just wrote a file in there and I was able to see it on Windows. Now I'm gonna add a file on the Windows FTP. Well, I need to figure out where the root is. And then I'm gonna access it from the Linux machine.
I think that is the best, because that's just.
No, there's like an active passive.
Anything that. Yeah. Because I always checked it before. Let's say you're in.
It's about passive. Oh, I do.
You should apply to, yeah, actually probably. It's for, very soon to be for less than one. That sounds cool. Wait, okay. How, there's like, I can all. It's a huge challenge. Yeah, I think they want to mask.
Like, they're gonna ask. Yeah.
I swear. This oh wait, it's just this.
It looks like using IIS with FTP, you have a few more configurations to deal with. That's always fun.
Yes. The return part.
It's separate.
You initiate a port from one, and then the data connection is on a different.
What's the like use case? Yeah,
I think it's more secure than. You still know how to use outbound connections. No, yeah, it's basically just so you don't have to do outbound. traffic. No, because even though like your stable firewall, it's like the outbound support connection is initiated by the server. Yeah. You really have to. Someone.
I could right now off the top of my head.
No, you couldn't have written one better.
I did, well, I wasn't.
Dude, they were making that space shuttle and someone was making FTP.
Well, that's tragic. Looks like I can't configure Windows FTP within like 5 minutes, so or however long it's been. Yeah, configuring anonymous access. I have the anonymous access. It just won't let me hit the directory.
Oh, you have to enable the SSD. And
Oh. Like this. Tragic.
Tragic.
Stick to XAMPP next time.
Oh, wait.
Yeah, what? Oh, from the other machine, yeah.
Oh,
It doesn't even say in product.
This is the other machine, right? Yeah. I already did. I put everyone. No, no.
Everyone is not.
Right. I'll try that.
Or unless the policy is set for space lock on.
No, it figures it.
It doesn't matter.
No, I don't want to open up Google. That's okay. Well, I think seeing all that struggling, we still have a gist of how FTP generally works anyways. I love testing in prod. Anyways. Hmm? Oh, you wanna take it?
Did you configure it in the GUI?
Yeah, I did. Why?
You did like the enable anonymous authentication
Yeah,
in the GUI?
I did.
Okay, you're just dumb.
Anyways, okay, so we have the general gist of how FTP works, I hope. General ideas there. We already set up on Linux. We were trying to do the same on Windows, but I hate Windows. So where was I? Do we have an idea? Let's continue the what we were doing before with threat modeling, FTP, right? Would anyone like to start us off with what is the functionality of FTP? That's awesome. Yeah, file sharing and file transferring, right. And from a technical standpoint, what are the requirements for FTP to actually function? In the case of remote access, we need accessibility to over the network via the port, and we needed credentials. What about in the case of FTP? Yeah, FTP does have to be enabled, but similarly to remote access, FTP is either gonna require, it's gonna require network level access and credentials or anonymous access if anonymous access is configured. So based on, yeah, in our case, it's just network connection. So I now trying to identify attacks. So if someone is, if a person is able to has those prerequisites already. So they have the network connection and they have the credentials if unique credentials, or if it's anonymous, they just have network level access. What can a malicious actor do with FTP based on its, I mean, what we've seen and with what its role is? Yeah, they can steal data. And if they have write access, they can also overwrite or delete data. In our case, that's not as much of a concern because all we had was anonymous read access because I couldn't even, I couldn't figure out the anonymous login and I can't figure out anonymous write. That's always been painful. But technically it is a possibility and something that you should look out for by manually connecting with your own client and performing tests that way. So
With that authorization will provision, right? For the users.
that makes sense. Okay. But anyways, I mean, and when okay, what does anyone have any idea regarding mitigations? How can you mitigate someone stealing data from FTP? Hey Ryan, how can someone mitigate stealing data from FTP? Sure, but what if we needed FTP to be on? Because it's a business critical service. Move the sensitive data if it doesn't need to be there. Especially if it's anonymously accessible, that's probably not supposed to be like that. Oh yeah, and in the case of CCDC, if you lose any sort of like PII, or any sort of sensitive information, yeah, fat deduction, it's crazy. So that's not fun. A VPN or encryption. If you restrict access to FTP behind a VPN, sure, that could technically work to mitigate network level access to it. That's not really feasible in the for CCDC though, unless you really want to put all the squeeze for that, then you can go for it. And encryption could help against sniffing, but if there's someone sniffing over the wire for that, but that's not as much of a risk that we've run into or seen personally. So still, like, those are technically possibilities though, for sure. But yeah, these first two services that we covered, generally somewhat common in CCDC. And they also, I mean, from what we could tell, not a whole lot of attack surface and not a whole lot they could do with it. They either have access or they don't really, because you could just cut them off with rotated credentials or some network level changes. And with FTP, there's not a whole lot of technical impact that they can do to affect the security posture of the system. They can steal data, but that doesn't necessarily affect your security posture. That just means, oh, dang, that sucks. We lost all your data. But that doesn't mean they pwned us. Still, that's still like skipping point A to point B, but whatever. We're moving into next lab, we're going to be talking about web servers and applications. These are by far the most prevalent services you will see in CCDC, and they are. Oh yeah, and the world too. I forgot. You know, I mean, we might be using websites every now and then, just a bit. Uh, yeah. So these are the most common things you'll see in CCDC. So they'll be they'll be the surfaces giving you the most providing most of the attack surface for attackers. And unlike the other two services, there's quite a few things you can actually end up doing to these services to that will very negatively impact your the security posture of the server. So web servers versus web applications. So web servers, some examples are IIS, Apache 2, and Nginx, whereas web applications might be something like XAMPP, Flask, or a lot of other things, like things written in like Node, things written in insert JavaScript framework here, that I'm not familiar with. But yeah, the difference between a web server and a web application is a web server the web server sort of serves access to the web, whereas the application actually performs like the backend functionality. So like originally web servers just sort of served read-only content from files that on the file system. That sort of evolved and changed a lot more now, where not only can they do just that, but they can serve access to an application that has a sort of virtual routing, so it doesn't necessarily need files that to exist on the system. There are just programmatically defined endpoints that when hit, it will return or perform specific functionality. Web servers can also act as reverse proxies or load balancers, so providing access to more backends aside from a single application. And they will typically be available on port 80 and 443. For our use case, we're just going to be working with a web server, and our web application is just going to be something really simple, PHP, some PHP stuff. So for this lab on Debian, we're going to try to set up Apache 2. And I didn't write this here, but we're also going to try to get PHP up and working. And on Windows, we're going to get XAMPP. XAMPP is going to come with Apache and PHP, so that's going to make our lives easier. I'm going to add some files to the web root to what do you call it? Just browse to them and see how the server responds to us. And then we're gonna add a funny file that I put a link to, and we're gonna add that to the web root and see what happens when we hit it with some specific URL parameters. Spend a lot of time on the first two, so we're gonna try to keep this one a little short and brief. This one should not take too long theoretically, unless I forgot how to do a lamp stack again. It's only been a year, but see. Okay, so it turns out I thought I had a fresh Debian image, just already had Kubernetes and a load balancer installed. So you're probably running into some issues, if you're trying to set up a web server. So I'm gonna speed run this real quick, and hopefully we don't blow up. Yeah, that's, my fault. I thought we had Debian 11 template. We didn't. Thought we had a fresh Debian 11 machine. It wasn't fresh. It is what it is. Oops. That's on me for trying to set this up like an hour ago. So we're just gonna disable all the existing stuff right now. Nice, it's all gone now. This is installing Apache 2, MariaDB, and PHP. And I'm gonna download XAMPP on Windows while we're at it. I'm going to click the first one and hope it works. Oh, I shouldn't have hit restart on K3S because now it's gonna bind to the port again and blow up probably. Don't do that.
Yeah, okay. I assume.
Yeah, I know, it's pretty. Bill has so kind of someone. Like.
And we're gonna enable PHP on Apache 2. Forgot how to do that. Right, it was just out of my path. I hate computers. Yeah, I don't remember how to install oh. Bruh. That's crazy. A2N mod, it's not finding PHP. I love installing stuff on different Linux distro and it all just doesn't work anymore. I love consistency, right?
I like how your kid needs to start.
Yeah, that's actually I forgot if it already supports PHP by default. Oops. Support. Yeah. Look, it looks like it worked. Okay, so you don't need to enable anything. Great, awesome. I love how it works differently on every distro. Is XAMPP done installing? Was I even installing it? What was it? Okay, right. Add this file. What's this file? Okay, that works. Okay. Crazy. We install everything except FTP since we already have FTP, although we probably should have done this to begin with. So since we have the web server set up on the Debian machine right now, I'm gonna access it from the Windows machine through the command line because I hate the web browser. I'm lazy. That's crazy. Oh wait, I'm hitting SSL by habit. That's crazy. Oh, it's over. It's so over. Huh? Oh, I mean, it's over for me today, honestly. It's just over. Um, um, um. What? The Kubernetes IP tables rule, pre-NAT rules.
Oh yeah, that is
Yeah. Oh my. I got Kubernetes. Oh my God. I got Kubernetes. It's over. Okay. I had a bad Debian installation basically, and there was some preset firewall rules that blew everything up remotely. Perks of setting this up at 30 minutes, no, 15 minutes, 10 minutes before the boot camp. You didn't even you didn't even stop the service.
I knew it was there.
I didn't know it was there. Anyways, so we can hit so we can hit our thing remotely. That's cool. Hopefully, is XAMPP finished installing? Yeah, this takes too long. We're gonna skip that now. But the idea is there, okay? We can go back to this last part, what do you call it? The threat modeling part. So what does a web server or web application do? What have we established so far from struggling in this lab and the slides I was reading over like 15 minutes ago? It serves information, right? Access websites online, right? These allow you to access websites, and these websites serve information based on whatever logic is being handled by the backend web application, or if it's just a web server, whatever file it's reading from. And from a technical standpoint, we don't really need anything aside from network level access and whatever application defined logic there is, right? So all we need to do is be able to hit port 80 or port 443. And if that application has some sort of is running some sort of actual thing, such as a store that requires you to log in, then you would also need credentials to access some of the application defined functionality of it. So based on this, there's a lot of different attacks that can happen, and this can vary. It varies mostly based on what the web server is serving and how the if there's an application, how does the application function? So there's a big reason why web is a very big focus when it comes to penetration testing, is because there's a lot of variation and a lot of depth that can go into it. And that's going to be a little out of scope of what we're doing here. What's important to us is that web contributes a lot to our attack surface. And what we can see that with the web shell that I had you guys write into shell PHP, but I named it test because I didn't read in my instructions. Because PHP runs in the back end, and it happens to it's easy to write vulnerable PHP code. It exports a lot of powerful functionality, such as being able to run commands on the host, in this case, the server, which we are actually able to do, which I told you guys to access a specific endpoint passing in a URL parameter, which the PHP code on the back end of the file that I had you write would then interpret as a command to run, which ended up returning some output. So in this case, the command being run was who am I? We could do a whole, an attacker could do a whole lot of other things. If this file wasn't here, this vulnerability would not be present. So when it comes to dealing with websites, the attack surface is highly dependent on what it's serving and the functionality of the application if present. It's a lot harder to deal with web and CCDC since it's very case by case. And there's not a whole lot of easy way to mitigate how an attacker can use a website to sort of breach your network, because realistically, you don't know the logic of the application that's running, because there could be a lot of different applications running. There could be, and those applications could have large code bases that you're unfamiliar with. So we sort of have to figure out like a more generic approach when it comes to dealing with web. And we also have to sort of accept some risk, such as they'll probably, if there's a command injection vulnerability such as there was here, an attacker is probably going to be able to exploit that. The way we would have to remediate that is so case by case. In CCDC, we may not necessarily have the time to do so. So our blanket, a good blanket approach is figuring out how to firewall access to firewall the server that's running the web application to prevent malicious callbacks. I basically just answered all the questions because we're running a little low on time. Let's see. We probably don't have time. Huh? Yeah. We probably don't have time to cover the entirety of databases because I had really poor time management today. I did not allocate the time very well because I didn't know how long stuff would take. But databases are often a backend resource that web applications will access. They store data. A lot of these services are self-explanatory, yeah, and there's a whole bunch of different types of databases, and they can operate on different ports, and they have different languages to interact with them, so it gets really annoying. And our CCDC team usually has a dedicated database person to prepare for all these scenarios, because databases are a lot, and because websites typically are going to depend on them to pull their data from, and if they can't, they end up exploding. These are very critical parts of your network. Originally, I was going to have you guys set up a database, work with the Apache PHP stack that I had you set up. We're running a little low on time right now, so we're just gonna skip that, but you could get back to it and try to work on that if you want to. You don't need to. But when it comes to CCDC, it is very common to see like a million websites and one core database that's exposed publicly. So it's just as accessible as the websites. So when it comes down to it, red team usually just sees, oh wow, database. Let me brute force the login and delete all the data. And all of a sudden you have 0 services up and you had no backups because you decide not to look at the database within the first like 30 minutes. And GG, you lost. I mean, that's like the TLDR of it. So there's based on these 4 services, there's a sort of, I guess, different priority you should have when you approach when you take your approach into the tryouts. And one thing that we didn't really cover here, but was sort of implicit, is inventorying your network, because you're gonna have a bunch of different services. You're not gonna know which ones are scored, and there are different services that have different levels of criticality to your network. Like losing a file share or having it exploited has a very limited impact compared to someone getting remote access on your system or your database being nuked, right? So a big part of the approach in CCDC is figuring out, is a part of that threat modeling where I was talking about, is like understanding how each service operates, so you know which ones to prioritize and how to, the quickest way you can remediate the relevant attack surface. What was it? Okay, yeah, application CCDC. There we go. Somebody said this one time, I don't remember who, but they said CCDC was basically an IT competition with a bit of a focus on security, because you have a lot of services. The security part is not super difficult. It's not like you have to follow best practices to get the job done. You just need to do the little stuff that you can very quickly, so then red team doesn't end up punishing you for it, because at the end of the day, red team's going to go after the easiest target. So if you're just slightly harder to hit than the guy right next to you, then that's good for you, because that means you're probably not going to get blown up just yet anyways. So over today, hopefully, so managed to set up, we've managed to set up and hopefully manage some services. I know I didn't. FTP pwned me, so there was that. And moving forward over these next 2 weeks, while as you guys prepare for the tryouts, and this is just my personal opinion, like looking at hindsight and everything, it's going to be very important for you to know the threat model for each of these common services. So understand, as we covered many times before, understanding how each service functions, how can its functionality be interrupted, and how to protect its functionality in the easiest way possible. So you can go about figuring out the other parts of the competition, like the injects, without necessarily like spending 2 hours on following the best practices on an Apache 2 config, which is going to realistically eliminate like 5% of the possible attacks while costing you like 80% of your time, right? And I left some examples there. One thing we didn't really cover, but hopefully you will be able to figure out, is figuring out if something's scored. If the scoreboard says HTTP and you have a web server, maybe that web server is scored. Because this is an example of the CCDC scoreboard, at least for the Western region. They don't give you the exact names, but they give you enough of an idea of like what you might be working with. Our scoring engine is a little more explicit, I think. I don't know which scoring engine we're going to be using for this upcoming tryout. But being able to go from here and saying, okay, we have X amount of services, they're running these types of things, and mapping that back to your network using the inventorying methods I was talking about, checking your ports, checking your services, seeing if it's on or off, and getting an idea of which one might be the one that's relevant. That's all called inventory. That part's going to be important, because once you know what information you're working with, you can go ahead and start doing all the whole security stuff and configurations that we are going over today. You won't need to be installing anything, but you need to be able to know how to secure it. So it's like, okay, maybe certain firewall rules work better here, or maybe the attack surface is focused on someone being able to log in. So all you have to do is change your credentials at that point. With that being said, are there any questions? I know I'm leaving you guys out early, but that's because I don't want to spend 5 minutes on databases and say, okay, yeah, that's it. So I'd rather leave you guys early so you could go do your own thing and spend these next 2 weeks prepping for whatever. Are there any questions or anything? I don't know. Yeah, what's up?
And so, you find out like, you find out what services are getting stored, like, as you know, starting.
Basically, when it came to the Western region, their scoreboard, they always left it publicly accessible, so sometimes we would be able to get a sneak peek, but in the case of the Childs and as we always hosted it, when you hop in, you will, that's when you find out what services you're working with. You'll have access to beforehand. Are we giving them a briefing packet?
Yeah.
Will the briefing packet have service information or just IPs?
Probably.
Okay, so you'll know the IPs and machines and creds you're working with, but you won't know your services. And that's strictly because that's how we've been used to it in CCD. We just kind of hop in and it's like, okay, scoreboard says we have 3 web servers, and an SSH, for example, right? It's like, okay, well, how many web servers do I see and which hosts are running SSH? This one has RDP. I don't need RDP, right? We should probably turn it off then because I'm not going to RDP into it. I have console access, right? Huh? Ooh, I forgot about that. We got a sheet on that, so should we give them a service sheet?
That's is
Okay.
That's is also changing.
Doesn't regional also do that? Then we're like talking about services changing.
Oh, well.
We got that like an hour before, actually.
Yeah.
So we'll
Do we do that hour before their chat?
yeah, let's plan
They
tryouts
gave
like right
almost
now.
no information that was useful, that wasn't on Sportsbook.
So we'll give them that information. Okay, scratch that response. We, new patch just dropped for the tryouts, according to Mr. Captain over here. So you'll have IPs on the briefing packet and you'll have not explicit service information, but some names that you can work off of, I guess. It should be obvious when, or yeah, it should be somewhat obvious when you see it, what you'd be working with, hopefully. Oh yeah, you want to explain more about the trial format, or have we already covered that in the previous weeks?
It's essentially like a CCDC trial, or CCDC style competition, like RVD format, where you're given a bunch of servers and hosts that you have to secure against a red team trying to, oh my god.
You want to repeat that for the ones on Zoom?
All right, for the ones on Zoom. The tryouts are gonna be basically a red versus blue competition with business injects. You will all be, it's individual, so you're not competing with teammates, you're competing by yourself. You'll be given several virtual machines to secure against a red team, trying to pwn them and trying to get information off of them, while simultaneously having to complete business injects, like we went over week 2. That's essentially the whole format of the competition. I believe it's gonna be 4 hours long, Saturday and Sunday, 2 weekends from now.
You won't be competing both days, though.
No, you choose. We'll send in a form, and you're gonna say which day you want to try out on. I mean, you could. We've had people do both days.
Wait, what?
Didn't-
Oh, like for fun.
Yeah, like for fun. Like
Weirdos.
you could if you do the first day, you could
Weirdo.
play again the second day just for fun, but that won't be considered, obviously. Yeah, I don't know. Are there any? That was kind of like a very vague explanation of the tryouts, but are there any like specific questions that I might be able to answer?
Well, because if you do Saturday and you go again on Sunday, right? It's
haven't-
like you already knew what was all the services, all the injects, right? So we're gonna have the same stuff over and over. We don't have that much manpower to make 2 separate tryouts with like completely separate content.
And then also that'd be unfair because what if one was like way harder than the other?
Oh yeah, dude. Yeah, 'cause- That's expensive.
Alright. Yeah, well, if you pay for it.
Anyways, yeah, so that should cover it for today. Thank you guys for coming. Hopefully, you got an idea of how to operate with services. I know that we've already covered operating stuff in the previous week, so combined with all this, hopefully, things are a little easier. But if there's any questions or you still don't know like anything, feel free to reach out on Discord or anything. I would say like probably last thing you could really prep for within these next 2 weeks is have a cheat sheet of what you want to do within the first 15 to 30 minutes of the competition, including things like whether it's specific packages you want to install, configurations you want to make, or in my case, and I think the most useful thing to me was firewall commands. Firewall is probably the biggest thing that you could do in this thing. I know we didn't cover it super heavily, because it's a very loaded topic, but if you can figure out firewall stuff, you can pretty easily remove all the services, or like all your concern about server security, because network security is very overpowered in CCDC. But yeah, that's about it from me.